That should be in the recording.
Yeah, and I just
turn everyone off.
I just purged the recording of that 6 minutes of fire alarm. So, all right. Last time we spent some time working on your assignments. Today we're gonna talk about the test format. Reminder: the test is coming up when? Wednesday. Very good. And then we'll take some questions and stuff from you guys, and we'll see where we're at. Okay. So the stuff I'm going through right now, the outline of the stuff to know for the test is all in your OneNote, so you can write this down or not. It's there for you. So you should be able to convert from radians to degrees or degrees from radians. That conversion factor would not be given to you. It's something I'd expect you to have memorized. You need to be able to calculate arc lengths. Again, no formula will be given to you. It's something I'd expect you to have memorized. You should be able to calculate the perimeter of a sector. You should be able to solve right triangles. You should be able to draw standard position angles. You should be able to find exact values of trig ratios using the unit circle. The 2Q or whatever, just how many questions of that type there are, right? You should be able to, given a point on the terminal side of an angle, find the 6 trig ratios. Should be able to, given one ratio and the sine of another, be able to find a specified ratio, so one of the other ones. You should be able to use the unit circle to evaluate an expression like cosine of 210 times sine of 135 plus tangent of 300 or whatever. You know, we had some questions like that in the review. Basically just looking stuff off the unit circle, right? You should be able to, given a parent function and a transformed function, describe the transformation. And then you should be able to, given a parent function and several transformations, find the final transform function. This is like stuff you did on that worksheet 2. And that's the test format. Blake, what's up?
So when you say solve right triangles, is that like the 30-60-90 triangle and the 45-45?
Or it could just be like any old right triangle.
Okay.
Like using Pythagorean or sine, cosine, tangent to find the side, you know, like this angle is 36 and the opposite side is 15. Find the rest of the sides and angles.
Okay.
You know, like stuff you did in geometry. Maddie.
You don't need to memorize the unit circle, right?
In this class, you will never be asked to memorize the unit circle at any point. Pretty much from this point forward, on every test you get, the unit circle will be on there. Unless it's completely irrelevant to whatever we were doing, like second semester stuff, that happens occasionally. But at no point will I ever ask you to memorize or reproduce the unit circle. You're welcome. You have better things to spend your time doing than memorizing that stupid thing. It's not really stupid, but.
Yes, it is.
Amanda.
What's this?
So like where the one arm is on the positive x-axis and the terminal side rotates. That's what I mean by standard position.
Oh, so is that one of the questions that's like given cosine in this thing, it's sine, it's less than?
It was more like on the homework quiz where I asked you to just draw the whatever.
Oh, okay.
That's more what I'm talking about. Teague?
What do you mean by give one ratio and the sine of another to find the specified ratio?
So it should be given. So that should just be given. So that would be like the last section of questions on worksheet 1. So like these kinds of things.
Oh, okay. Thank you.
Yep. Ari, I saw your hand up.
Oh, it was the same one.
Oh, okay. Yeah, give and given probably makes a big difference, right? I'll sneak a sloppy N in there to go with the rest of my sloppy penmanship. Sorry, guys. I try, but sometimes by 8th hour, it's just like, you're just tired and your penmanship goes to caca-boo-boo. Maddie!
Is arc length the table that we had to do?
So some of the arc length questions were formatted to like fill in the rest of the values in the table. Some of them were just like a story problem. Some of them were just like, just kind of depended. But yeah, some of those were, some of them were formatted as a table.
Where are we going to get those story problems on the test?
You could. If they fit into like one of these question types.
Gotcha.
Okay. Any more clarification on test format or whatever kind of questions? Okie dokie.
Wait, actually, sorry. So what do you mean by draw SP angles? What is that?
So standard position.
Oh.
So just like we did on the homework quiz, right, where I asked you to draw the picture. So that's all we're talking about. So no calculation, really, right? Just drawing. Drawing a spiral. Bad.
For the unit circle one, like if it's anything above like 2, let's say it's like 11 pi over something, it would be, you always use 2 pi, right? Like that's what you minus it by until you get to a number that you can actually do.
Right. So if you're finding an angle that's coterminal, you're either going to be adding or subtracting 360 degrees or 2 pi, depending on whether your angle's in degrees or radians.
Always 2 pi and 360, nothing else.
Yes. If you're looking for coterminals, which is the only thing you'd be looking for right now. Yes. So for right now, it would always be that for those kind of questions. Okay. Let's deal with some specifics then. If you guys have specific things you'd want to ask about, whether it's a specific question or it's a topic or whatever,
What questions on the review or
any place would be fine. Jake.
Can you do number?
Okay. Okay. So for these kinds of questions, I'm going to be using the standard position angle definitions of sine, cosine, and tangent. So I know that sine is really y over r. So I know immediately that y is 1 and r is 4. I know it can't be y negative 1 and r negative 4 because the r is a distance. It's the length from that point on the terminal side to the origin. So since the r always has to be positive. Okay. Similarly, if tangent is y over x and y is 1, so that means 1 over x has to be negative, so I know immediately that x is negative. Cool with that? Now I'm going to draw the picture. So x is negative, but y is positive. So we're going to be over here in this quadrant. So far, so good. I'll draw my triangle. So the x is negative, the y is 1, and the r is 4. So I can solve for that x side by using the Pythagorean theorem. So that's going to be the square root of 15. So that point then is negative square root 15 comma 1. And cosine, I remember, is just x over r. So I'm done. So the difficult part is really just kind of filling in or drawing a picture. And really nowhere in here did I do any really complicated calculation, right? None of the algebra was really difficult. It was just making sure I'm using the correct definitions for sine, cosine, and tangent. So I'm able to ascertain the quadrant that I need to be working in. 13? Sure. So cotangent, I know, is x over y. So I know that either x is -4 and y is +3, or x could be +4 and y can be -3. I know this could be either or because x and y are representing coordinates here, which can be positive or negative. Sine is y over r. R is representing a length, so it's always positive. So I know that the y is negative. So the situation I have is that one, where the x is positive and the y is negative. Is that okay, Billy? Okay. So I'll draw my picture here. So x is positive, y is negative is down here. So there's my theta. Draw my triangle. So 4, -3. And then using the Pythagorean Theorem, I can find r. And so the last thing I'll do is cosecant of theta, which is equal to r over y. That's 5 over -3. Does that feel okay? Okie dokie. Jake?
Can you just go over like over time, like sine is equal to
Sure. So for right triangles, we have SOHCAHTOA, right? So sine is opposite over hypotenuse, tangent is, or cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then we know the reciprocal pairs. You know, sine goes with cosecant. Cosine goes with secant. And then tangent goes with cotangent. So the way to remember the standard position angle definition, it's the same as SOHCAHTOA, except opposite is y, hypotenuse is r, and adjacent is x. So it's still just SOHCAHTOA, we're just making some substitutions. And then the reciprocals are just that. So this is our standard position angle definition. So to go from SOHCAHTOA to this one, we basically just use those substitutions. And our last definition was the unit circle definition, where sine is y, cosine is x, tangent is y over x, cosecant is the reciprocal, so that's 1 over y, secant is the reciprocal, so that's 1 over x, cotangent's the reciprocal, so that's x over y. then to go from here to here, basically all we're doing is filling 1 in for r. So mostly all you really need is SOHCAHTOA, and then to remember just like, okay, which ones are the reciprocals, and then a couple of substitutions, but it's all these definitions are essentially just like minor modifications of SOHCAHTOA. Does that help? Sure. And again, that's the way that I remember them. It's all basically just still SOHCAHTOA. And again, all this stuff is going to be in the OneNote, right? It'll all be in the content library in case you're like, oh, I don't know if I wrote that down right, or I didn't write that down, or I just was like watching and listening. What was that again? You know. But all that stuff there that we just kind of outlined is for sure stuff you'd want to have memorized, right? Or at least memorized how to get it. You know. I'm not a big memorize kid as a high school student. I'd rather like, okay, I got SOHCAHTOA, that's easy. There's a nice acronym for that. And then how do I get the other things from SOHCAHTOA? I'll just remember how to do that rather than like memorizing a new set of things. You know, I was an understander and then I'll remember it versus I just need to memorize it without understanding it. It did not ever work for me and have that kind of memory. Blake?
Okay, so for questions 47 through 50, on the homework, I'm a bit confused on what you're asking. Are you like asking what the positive, and you're asking like whether or not they'll be positive or negative at 90 and 180 degrees?
Nope.
Oh.
We're asking if an angle falls within the given interval, so we're saying theta is going to be greater than 90 and less than 180, is what we're saying.
Okay, yeah.
So
it's in between.
Yeah, so if you think about that, 0, 90, 180, we're talking about things in quadrant 2. So that's where the x is negative and the y is positive. So I remember that sine is the y coordinate, which is positive. Cosine is the x coordinate, which is negative. And tangent is y over x, which is positive over negative, or just negative.
Yeah, that makes sense.
Jake.
And then because she's asking about an angle,
Yeah, so I'm using the unit circle
Yeah.
definition to do this. You could use the standard position angle to do it, and it wouldn't change because r is always positive. So like you can make the same conclusions from that also. I just was using the unit circle definition, so I didn't have to think about r. But that would be fine still. Alexis? Sure. So I'm going to draw in the radian measures here. So I have every 90 degrees is pi over 2, right? You could calculate that using the conversion if you needed to, but so a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, and then to 4.5 is quadrant 1. And in quadrant 1, I know they're all positive, right? Hey. There we go. Since x, y, and r are all positive there, then everything's got to be positive. Is that cool, Alexis? The other option there you could have done is you could just keep subtracting 2 pi from both sides, or from both ends of your interval. to find angles coterminal to it that are like inside the unit circle. And then again, it's easy to tell you're talking about quadrant 1. You can think about it that way also, if you didn't want to draw the picture. But I often think that the picture just kind of helps. I'm a visual guy. I like drawing the pictures. You know, some of us are computational people and like, okay, I'm just going to think about it computationally. I don't want to draw pictures. But I'm a seer. You know, some people are like writers. Anyways, who's next? Amanda.
For 51 to 54, I'm confused at like all the
Okay, the final outcome is not. So you're going to get the same answer regardless of how you're doing it. The unit circle would show no work. The reference triangle is going to show some work. So let's show what the work would look like. Okay? So let's say we're just going to do 51. So we'd start by drawing that standard position angle of 150 degrees. Cool so far? Okay. We'll draw our reference triangle. This angle here has to be 30 degrees. Why is that? 180 minus 150 is 30, or you could think 150 plus 30 more gets you to the 180, which is the flat line. Does that make sense, Amanda? So that means that this one has to be 60, and what we're dealing with is a 30, 60, 90 triangle. So since we're in the second quadrant, I know the x direction is negative, but the y direction is positive. Since it's a 30, 60, 90 triangle, the ratios are a root 3, and then 2a. So far, so good there. Yes?
Is that always what it's going to be, or is that are the numbers going to change? Is it always going to be a,
Well, I mean, respective of the angles, right? Like if the 30-degree angle is your reference angle, then yes. If the 60-degree angle is your reference angle, then you know the a and the negative, or the a and the a root 3 would switch places.
Okay.
Is that what you're asking? Okay. So we've done that. So then we can just do cosine of 150 then is going to be adjacent over hypotenuse which if we looked on the unit circle is the same thing we have as the x coordinate at 150, right? We're doing the same thing, it just one of them is showing the work. One of them is just shortcutting out through all the work. Notice on the test questions, I didn't have anything where I asked you to use a reference triangle to do da-da-da-da-da. Mostly because I want you to get used to using the unit circle more than building these reference triangles out. We'll come back to them again. They don't go away per se, but the unit circle is so nice and useful that I want to emphasize that part right now. Who's next? Happy to do more. Dom.
The last question on the repeat.
Okay. And I'm going to need a unit circle to do this. So I'm just going to drop that in right next to it. Okay. So you're talking about this one, right? Okay. So the question becomes, how do I deal with these squareds, right? So sine squared 30 is the same thing as sine of 30 squared. So to go to do this, I'm going to go to my unit circle and find 30 degrees. The x-coordinate is root 3 over 2, and the y-coordinate is 1/2. Oops, that's not what I wanted. So far, so good. 1/2 squared is 1/4. Root 3 over 2 squared is 3/4. I add them together and I get 1. Why is that not surprising? Because really what we have here is y squared plus x squared, and I know that should equal r squared, which on the unit circle is 1. Oh, sure, when you point it out that way, of course the answer was obvious. I shouldn't even have to do the calculation. It wouldn't have been obvious to you. Maddie!
Can you do the D-verse order?
Sure. Blake, did you have a different?
That was the same thing.
Okay.
I'll look at it.
So first thing I notice is that neither 22 pi over 3 or negative 16 pi over 3 are unit circle angles. So what I'm going to do is find something coterminal to them. And you could do this a couple of different ways. I'm going to do it numerically. So 22 pi over 3. I'm going to go to my calculator and just drop the pi's and just do 22 over 3. And then instead of subtracting 2 pi, I'm just going to subtract 2. And I'm going to do that until this number is between 0 and 2. So there it is, math frac. So that's going to be the same thing as 4/3 pi. Oh, that's good. I put it in there. I was just looking at the wrong question. I was like, that's not what I did. We'll do the same thing with negative 16 pi over 3. Again, I'm going to drop the pi's. And this time, since it's negative, I'm going to be adding 2 until I get something between 0 and 2 pi. So I do that, and I have 2/3. I don't even need the calculator to tell me what that fraction is. So 2/3 pi. Everybody okay there? I'm going to go to my unit circle and locate 4/3 pi. There it is. And I'm going to take the x-coordinate. And then I'm going to go to my unit circle and locate 2/3 pi. There it is. And take the x-coordinate. So negative 1/2 and negative 1/2 is just negative 1. Matt, do you feel okay there?
Yeah.
Alternatively, if you preferred to not find those coterminal angles computationally, we could have just found them geometrically. So like if I take 22 and I divide it by 3, that's 7 remainder 1. So basically it's 7 1/3 pi. Is that okay with everybody? So if I go to my unit circle then, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, and then 1/3 more puts me right here. at 4 pi over 3, exactly as we found computationally. So you could also do it geometrically just by kind of drawing your standard position angle. You do a lot of spins or whatever, but you could have also found those coterminals that way. And that's okay also. Dom?
So why would you take the x for the sine of 2 pi over 2?
So I think I took the y. Oh, did I write down the wrong thing? I did.
Yeah, I was gonna say that.
I'm glad you said something. Goodness, great googly moogly. So since they have a common denominator, I'll just write them as a single fraction that way. My apologies. Thank you. That's what I get for not highlighting the coordinate that I'm taking. I probably would have caught it. Okay. Who's next? Blakey.
Should you be in that same section?
Oh my goodness. You guys love these. Do you want to find the coterminal angles graphically or computationally?
I did it computationally.
Okay,
so
let's
either
do that.
one works for me.
Negative 23 over 6. Going to add 2 a couple of times. Make that into a fraction. That's pi over 6. Oh, which one did you say?
Oh, B.
Oh, I'm doing the wrong one.
Boy.
Why didn't
You
you?
could use C2. I didn't have much trouble with that.
All right. So this is even easier because I can just, yeah, it's all in degrees, so it's not even like anything sneaky. So sine 225, and then 855 minus 360. That's 135. So I go to my unit circle. Sine of, I find 225. Sine is negative root 2 over 2. And cosine of 135 is also negative root 2 over 2. That's just 1.
Okay. Cool.
Everybody cool beans on that one? NBDs, right? Who's next? Peyton.
Can you do C from the section about that?
From page 6 then? Sure, I think I have that page yet, do I? I think I did. Just double check. Oh, I do have that page, right? No. That's from the worksheet, not the review. Okay. So 9C here, right?
Yeah.
Sure. So to do these ones, I'm going to be using the standard position angle definitions. Cosine is x over r. So that tells me the x is negative root 2 and the r is positive 2. I know the r is always positive, so the negative sign is always going to go with either the x or the y. Cool with that? Okay. And I know sine is y over r, which is positive. And since r I know is positive, in fact, we just say r is 2. Tells me y has to be positive, right? Okay, so now I'm ready to draw my picture. My x is negative, but my y is positive, so I'm going to be in the second quadrant. I'll draw my reference triangle. So the x is negative root 2. The y is what we're looking for, and the r is 2. So using the Pythagorean theorem, I get that y is the square root of 2. I just did that in my head, but if you don't believe me, you can try it for yourselves. And that's all I really need, because now I can say, okay, well, tangent theta is y over x. So this point was negative root 2 comma root 2. So this is going to be root 2 over negative root 2, or negative 1. So this was what? 135 was what theta was. Holy smokes! Or something coterminal to 135 anyways, right? There's infinitely many answers.
We know that r is positive, the hypotenuse can't be negative.
So remember in standard position what these are representing. X and y are representing coordinates for a point, and r is representing the distance of that point to the origin. So since the r is always a distance, always positive, x and y's are coordinates, they can be positive or negative. So we're just kind of drawing this hypothetical triangle that's not a geometric triangle. It's not representing distances and lengths other than the hypotenuse. The other sides are just representing coordinate values, which can be positive or negative. That's why we're allowed to give positive or negative side lengths here. Other questions? Happy to do more. I'll take a little soda sip here while you guys are thinking if there are any more.
Question 6. D.
From the review?
Yeah.
What page is that on?
5.
Okay. Don't think I have this page yet. What am I doing here? So you said question 6B. Okay, so it just says to find two angles coterminal with the given. So this angle for B is clearly given in radians because there's a pi in it. You good with that? Also, there's no degree symbol, so we know it's radians if there's no degree symbol. So I can either add or subtract 2 pi to get a new coterminal angle. It doesn't matter which one I do because it doesn't give me any other specifications than just finding something coterminal. So I'm just going to add 2 pi, and I'm going to do this with the calculator, so I'm just going to drop the pi's. So instead of writing 2 pi over 7, I'm just going to write 2 over 7. And then instead of adding 2 pi, I'm just going to add 2. And then, ask the calculator to give me that back as a fraction. So 16 pi over 7. You good with what I did there, Billy? And then I can just add 2 pi again to get another one. So 30 pi over 7. Those will work. You could keep adding 2 pi. Every time you're going to do that, you're going to get a new coterminal angle. There's infinitely many possible answers. You could have also, instead of adding 2 pi, you could have been subtracting 2 pi. And you could do that as many times as you wanted. Those are all good answers. There's infinitely many of those. Does that feel okay? Blake?
So on this test, this next, or on Wednesday.
Yeah.
So do we have to fully simplify roots when there's a root in the denominator? Do we have to multiply it out?
Yes.
Okay.
Yeah, that would be the expectation, is that you'd give answers with rationalized denominators. I think what we had said was if the radical in the denominator contains only constants, we'll rationalize those. If it contains variable expressions, we'll just leave those be. Was kind of the expectation that we had set at the beginning of the course. So if you have 1 over root 2, I'd expect that rationalized. If you had 1 over root x, I wouldn't worry about it, although surely that's easy to rationalize. But I wouldn't complain about that one. Get what I mean?
I do get it.
Cool. And again, on a test or whatever, if you're unsure, hey, did I simplify this enough for the answer? You can ask and be like, okay, so the directions say, but I'll point that back out to you or whatever, and be like, if you did that, then yes, you're good. If you didn't do that, maybe you want to take a second, I'll give you some kind of idea. Or I'll just be like, yeah, okay, so the directions don't really say, so that what you gave is fine, or whatever. Or I'll tell you, can you rationalize the denominator? And you'll be like, all right. You know what I mean? If you're unsure, you can ask. That's no big deal. If the directions are clear, I'll just refer you back to the directions. But if they're not, I'll tell you. I get it. You know what I mean? To some extent, it's about preference. And you guys are still trying to figure out my preferences because we only had one test. That's all fair. No big deal. Okay. Anybody else? Happy to do more if you guys got more. If you don't, that's okay too. Okay. If you would clear your desks of everything other than a calculator and a pencil. It's this homework quiz that you knew was coming. Because it's been 4 days or something since the other sections have had it, so I'm sure they told you about it.
I think I'm going to need a highlight for this test.
Yeah.
These were the contents of my comments. Oh, wait.
Yes, sure. I don't think you'll need time, but I'm happy on one. I would ask you to take a look at it first, and if you run into a spot where you think you want it, I'm happy to give you one.
That works for me.
This is one where the intention is to just use the thing without a calculator. You don't really need one. I mean, you can have one if you want it. I'm not saying you can't. But I don't think it's really enough. You're welcome.
But I'd be able to use it just so it's
Yeah, that's okay.
Thank you.
You're welcome.